Hello and good afternoon. Welcome to today's webinar from Safeguard Europe Limited. Penetrating damp, causes and treatment. I'm Damien Wallace, Technical Manager. I'll be moderating today, and alongside me is my colleague Michael Pryor, Development Chemist, who will be doing the presentation today. It should take about 50 minutes to go through, and at the end of the talk we've allowed about 10 minutes to answer any questions. There is a link below in the YouTube description where you can submit questions during the presentation. An increasing problem in the UK, exacerbated by higher intensity of rainfall in recent years and a large industry focus on installing cavity wall insulation, has led to properties that previously had no issues with dampness to suffer from the effects of rain penetration. The damage that penetrating damp causes is not only unsightly but can also be very costly to rectify. So today's seminar presents a thorough look into penetrating damp and the modern day treatments available to prevent or rectify it. We'll explore details of the causes and common symptoms of penetrating damp, with a focus on understanding how the building envelope operates in relation to moisture penetration. We also suggest provide a suggested surveying procedure, and various types of treatments available for penetrating damp are assessed. Hopefully by the end of the seminar you should have a good understanding of how to start solving rain penetration issues. So anyway, that's enough for me as an introduction. So Michael, over to you for the presentation.
Okay, thank you, Damien. That's great. So like I say, this is the Penetrating Damp webinar by Safeguard Europe. Just very quickly, just say who we are. So we are based in Horsham, been around for about 30 years, and we specialise in damp proofing, waterproofing, structural repair, and timber preservation. We have a large technical department of 4 research chemists, and we've done collaborations with a number of universities, such as Portsmouth University. Some of the main brands which hopefully some of you will be aware of will be Dry Zone, Dry Base and Roxil, but the one that will sort of be most apparent during this webinar will be Storm Dry. So like Damien said, the main learning objectives will be about what is penetrating damp, what are the symptoms, what causes penetrating damp, and then going through the treatments for penetrating damp. So there are 3 main types of damp: rising damp, condensation, but the one we'll be focusing on is penetrating damp, which is effectively wind-driven rain penetrating into the structure through the masonry. So basically what is penetrating damp? So it's the process of moisture, usually rainwater, entering a house. So you can see in that picture there are quite a few routes where it will come in. And usually where it comes in is due to wind pressure. So in areas that are quite exposed is where you get a lot of wind-driven rain. Any cracks or joints where there's defects in the masonry. And then other sort of exacerbating factors such as poor roofing where the gutters are blocked, moss in the roof, and other sort of poor design work in the actual construction and any renovations of a property. So the main symptoms of penetrating damp. So there's quite a few visual symptoms. As you can see through these pictures, quite a lot of times you'll see some form of decorative spoiling on the inside of the wall. It can be quite common to be seen around sort of window sills. Anywhere where there's basically a window, you can quite commonly find penetrating damp. And any sort of musty odour as well is quite common as well. Another factor which is not apparent in terms of visually, but in terms of sort of your energy bills, is loss of thermal resistance. So it's been researched by the University of Portsmouth that a wet wall will conduct more heat than a dry wall. And that's effectively the same idea as where you put wet oven gloves on to take, say, a hot tray out of the oven. You'll actually burn your hands. It's the same sort of idea. So it's shown here that a wet brick will conduct away twice as much heat as a dry brick, and so by doing that it's going to increase the amount of heat loss in your property, and so will especially during these winter months, increase your energy bills. Degradation of the masonry. So over time, rain falling on a surface will start to damage it by corrosion and just sort of dissolving away the binders, such as lime or even cement over time will dissolve, especially with acid rain. Freeze thaw action. So over time, if the bricks get wet and then get frozen overnight, they can start to crack. And any sort of corrosion of the wall ties and within sort of cavity walls can become an issue. Timber decay. So if a wall is allowed to get wet, certain types, if it gets to a high enough level of moisture, certain types of rots can start to develop in the timbers, especially dry rot and wet rot. Especially when they're embedded into the wall, it can be very common for that to happen. And so usually as well, another sign of decay in your timbers is any signs of wood boring insects such as death watch beetle. So the other little fact, which is sort of more on the occupancy, the people who live in there, are the health effects. It's been widely shown that excessive dampness in buildings can have negative effects on people's health, and penetrating damp is one of the main causes that can actually create the dampness. So it's been shown by quite a few different organisations that an increased amount of moisture will create sort of mold, allow good conditions for mold spores, and these mold spores can have a detrimental effect on people's health, such as respiratory issues, which can actually have a lasting impact.
So you could say that there's a good case for penetrating damp affecting the surface temperature of external walls, which in turn could then lead to condensation issues developing internally as well.
Yes, so the idea that the wet wall slope will become cold and allow the propagation of condensation. So why is it quite important to fix penetrating damp? Especially for any sort of landlords. In 2018, the Homes Fitness for Human Habitation Act was legislated, and essentially there's quite a few criteria about what a habitable space is for tenants. You can see there's quite a few, such as lighting and ventilation and sort of cooking facilities. But the one we're sort of interested here is freedom from damp. And essentially, any sort of tenanted property that has damp and the landlord is made aware of it, they must fix it now. And if they don't, then this law allows tenants to effectively take them to court, which they couldn't before. And there was a YouGov study done in 2019 on how many people were actually aware of this new law. And at the time, so in 2019, only 1/3 were. So I imagine there'll be a lot higher now as it becomes more known. So that's the symptoms. So now we're going to look at the actual causes of penetrating damp, and then we're looking at how they can be dealt with. So there's sort of two main routes. So one is the primary paths of rain penetration. One is porous masonry material, so capillarity. So all bricks have some form of pore structure, and depending on how porous they are, will decide how much moisture they absorb. And the other one is masonry defects. So basically the idea of cracks or any sort of like areas where moisture can just pass through the wall and get into the inside of the property. And the other thing to be aware of is exacerbators of rain penetration. So this is anything that allows rainwater to bear on a particular section of wall or usually like prevents drying. So we're looking at the ideas of defective rainwater goods, so gutters, missing seals, poorly conceived detailings, non-breathable coatings is quite common, and then also the other sort of ideas of the location of the wall and anywhere where there's sort of high periods of extreme rainfall, such as in 2013-14, there was a high amount of rain, which meant that the wall got especially wet and reduced the amount of drying. So how do you treat rain penetration? There are two ways. You've got primary measures and secondary measures. So primary measures include fixing the primary paths of rain penetration and any exacerbating factors. Secondary measures are basically where you're trying to do backup measures. So the idea that if any of the sort of primary measures fail, you have an internal system which should accommodate it. So use things such as damp-proof plasters can provide secondary protection. So in terms of fixing a penetrating damp, it's a good way is to follow this sort of 4-step process. So the first step is to assess the amount of moisture in the property. So you're looking for where the moisture is getting in and looking around and doing effectively a survey of the property. The second step is then to look for these primary paths of moisture and looking to treat them. So this is where you would look to fix any cracks in the wall or any sort of repointing work, and then looking to fix any porous masonry by applying a brick cream such as Storm Dry. And then you'll be looking at the third section, which is controlling any exacerbating factors, so looking to unblock any gutters and removing impermeable coatings and any other sort of factors that allow moisture to sort of build up in a certain area. And once these have been sorted, you then look at your secondary protection. So once you've stopped the moisture getting in, you then maybe renovate the internal property so that there's a second line of defence in case any sort of moisture does get in. So the installation of a damp resistant plaster would be used.
I think additionally that offers the opportunity for the wall to dry out. Certainly with the more modern renovation plasters, it means that the wall can dry out once it's been treated externally, as an opportunity to evaporate out internally as well.
Yeah, so using sort of new modern plasters is usually the best sort of remedy compared to using sand and cement as a way of renovating a property. So looking at those primary paths, so where are these masonry defects? So even very small defects in masonry can allow moisture to pass through, especially when there is a build-up of wind pressure that can allow moisture to pass through. So the following sort of slides will show the most common defects that allow rain to penetrate a property. So the first one is defective pointing. So even on fair-faced masonry, pointing will degrade over time. So this should be repaired. You can use such things as ready-to-use lime and sand putties, for instance. But it's always recommended to use the same sort of pointing that's already there. And the best advice usually is to follow the BRE guidelines in their sort of good repointing guidelines. So something like a 6-to-1-1 sand and lime and cement mix is usually quite good for most cases. And in terms of finishing the pointing, you should use either a bucket handle or flush finish, which offers the best rain resistance. And it's not advised to use recessed finish. When you are fixing any pointing, it's quite beneficial to add any sort of repointing additives. So Storm Dry repointing additive number 1 can be added as a gauging solution to the mortar mix, and now add waterproofing properties to your mortar, while also having the added benefit of reduced shrinkage. So one of the reasons you get rain getting in is that the mortar shrinks away from the joints. So this additive actually reduces that, while also not affecting the breathability of the mortar and increasing the waterproofing properties. So when you have any large cracks or small cracks, these need to be filled with some form of fine mortars or polymers. Large cracks may require crack stitching, or actually a further investigation of why the cracks have appeared, so such as any sort of like structural movements might need to be investigated. So in a situation where you have got large cracks, materials such as brick fix can be used. So that's the helical bars, for instance, and the grouting can be used. Can be embedded with a specialist mortar to stop any movement cracks within the wall. So once the bars have been installed, the crack can be filled with a suitable mortar or sealant. But be aware that the underlying cause of cracking, such as like subsidence, should be rectified first before doing this work. Holes, so very commonly can be found in old properties, but also even in new properties where, for instance, if someone's had a new satellite dish installed, when they install it, they might drill a hole to secure their ladder, and they finish the work and they leave the hole there. So that can easily be a route for moisture to get in. So in those situations, they should just simply be filled with a long-lasting mortar or a polymer. So the picture there, 2 pictures at the bottom there, was of brackets that were removed, and simply in those situations, it was filled with a polymer mortar, such as XR mortar, and then a sprinkling of brick dust was put on top to match it into the brickwork. Unfilled joints and perpends. So it's a very common sort of problem for single skin walls where the mortar lines haven't been completely filled, and so where any moisture does get in, it can then start to collect and also start to penetrate to the inner surface. Defective flashing. So on older properties that have not had their roofs looked at for quite a few years, quite commonly find that the flashing is corroded or even been poorly installed, and simply this should be replaced and rectified. So in this situation, it's best to get some form of roofing specialist in. So you can see here that you should replace it with new LED flashing. It could also be repaired with a temporary roof tape membrane, so that could be done as a sort of short-term fix before getting an expert in, and that would be sort of the best advice when trying to look at rain penetration. So like I said earlier, quite a lot of rain penetration can come through the windows, and that can quite commonly be due to defective sealants used around the windows. In these situations, a cheap silicone might have been used, and over time they will degrade in UV light. So basically in that situation, you just need to remove the old sealant back to a sound surface, and then apply a sort of higher grade one. So on the market you can buy these MS polymer UV resistant sealants, and these are far more effective and durable. So they should last up to about 10 years in terms of lifetime and have a much better performance.
I suppose this is a particular problem where you have timber frames, doors, lintels, windowsills, where obviously timber will expand and contract subject to moisture conditions, and obviously if the sealant is too rigid, that's going to cause problems there. So
yeah, so depending on the sort of surroundings of the wall and the windows, you need to take into account what sort of sealant you're going to use. So it's all about just taking it by a case measure and trying not to use the same one for every single job.
Question we often get asked, Marco, on this subject, I hope not to put you on the spot here too much, but is which order would you apply a sealant? Would you apply the sealant first and then apply storm dry, for example, or would you apply storm dry and then the sealant?
In most situations, we would recommend applying the sealant first. So in terms of any sort of structural work, it's good to fix any defects such as windowsills and repointing work first, and then apply storm dry. As storm dry makes the wall slightly water repellent, it may affect the adhesion of some of these products.
Brilliant, thanks.
Okay. So now we're moving on to quite a common issue for rain penetration is defective render. So render has been traditionally used as a way of covering up poor quality absorbent brickwork. So quite a lot of Victorian properties were built with underfired bricks, and because of that they effectively absorb moisture very happily. So in those situations they were rendered over, especially with cement based render, and so if any small defects or cracks did appear, the moisture would then get trapped behind them and would effectively act as blotting paper and spread the damp throughout the wall. And this can be made worse if the render is covered with a vapor impermeable paint, so an acrylic paint make that a lot worse. So in those situations, there are sort of three main options. One is to actually repair the render that's already there. Second option is to replace it, and then the third option is to replace it with external wall insulation. So you can see in this picture the any cracks that are present in the render will allow rainfall water to enter. It will then start to collect, especially because the brick behind it will likely be highly porous, and then eventually start to reach the internal face of the wall, so you're getting damp patches on the internal plaster, and because of the low breathability of the material, there'll be less drying, and so the actual property will stay damp. So actually in those situations, often the best solution where possible can be to, if there are small areas of render that are affected, is trying to fix those, but checking that the underlying masonry could also be fragile, so care must be taken. So if you are trying to repair the defective render, it's trying to match the strength of the existing render, so it looks in place. So this can be done by sort of replacing rectangular blocks of the render, as this is less noticeable than following the exact shape of the damaged render. And also in this situation, you may have to also fix any sort of underlying cracks as well with some form of crack stitching materials too. So you can see in these pictures where there are cracks in the render that have been previously filled can hide much larger cracks actually hiding underneath. So in this situation, the crack needs to be stitched using stainless steel helical bars, and the void can be filled with some form of lime putty and sand as the initial treatment, and then simply as a way of fixing it, the render can be applied to closely match the underlying render, the existing render. So in this case here, the late Victorian render was quite hard to identify. So therefore, we used a 6:1:1:1 mix to match the same strength, colour, and sort of get a good appearance. But for quite small cracks in filler, it can be also just as an alternative to do sort of patch repair. So small cracks can be filled using sort of epoxy or MS polymers, or dispersed hydrated lime. So these are quite good for any small areas where you just need to block the rain getting in. But it only requires a small amount of movement within the wall for that crack to open up again. So it is always a short fix, so be aware of that. But also there can be situations where you turn up at the wall and quite small fine cracks in otherwise sound render do not actually need chasing out or filling, especially where the render is treated with a water repellent cream or a silicone resin paint. But it's always worth checking the condition of the underlying masonry, and if there is any exposure to wind-driven rain, whether this needs to be taken into account. So where render is to be painted, a water repellent fine filler might be used to fill fine cracks, and then these should be allowed to set before sanding. So in this situation, you could apply your render and also add a gauging solution such as repointing additive number 1. And in terms of when you are doing any defective render work, the actual cost is often little more than repair once cost of scaffolding. So for instance, the amount of cost of scaffolding can cost compared to the actual work done, and also the work being done to fix any underlying cracks. So it's just a case of working out whether the payback is worth the amount of work being done. So one of the other ways of repairing defective render is with EWI, so external wall insulation. So this is a good way, especially in the new sort of energy world that we live in, of saving energy. Just be aware that it's not suitable if buildings suffer from other forms of dampness, because if the insulation gets wet, then it won't reach its full potential in terms of its energy saving properties. and also can be hard to accommodate in areas where there's deep window recesses. And also, in terms of the house itself, it will change the appearance of the house. So the homeowner must be made aware of that, and permission must be granted too.
I suppose the other thing to consider as well is the effects of if you do have residual moisture in your wall as a result of penetrating damp or other forms of dampness, and you install external wall insulation, reducing the ability of the wall to evaporate out externally.
Yes.
So it can make a small problem seem worse than it originally was.
Yeah, so in terms of if external wall insulation is put onto a property, the idea of you should take a whole house approach to renovation work. So there is a presentation done by Safeguard about past 2035, which takes that whole idea about how to retrofit a property for energy saving purposes. So it'll be well worth your time listening to that if you need more information about EWI and its effect on damp. So you can see here that a BRE report talked about solid wall heat loss and effectively the potential energy savings, but also described the pitfalls to be avoided when installing EWI. So it emphasises the importance of EWI in terms of meeting carbon reduction targets, but also the sort of damp issues that can become apparent if it's not correctly installed. So that's the masonry defects. Now we're just now going to look at porous masonry, which is another common path for rain to get into a property. So as we know, it's actually quite surprisingly common to find external walls are formed of porous material. So bricks themselves, if you take a common flattened brick, it can actually absorb about 20% of its weight in water. So if you imagine you take a standard wall, the amount of water that can suddenly be absorbed by it is a lot of water. So what is porosity? Just very briefly, so porosity is a measure of the void spaces in a material. So the idea is the amount of voids divided by the total volume. So more voids equals a more porous material. So you can see here that something such as granite will have low porosity compared to a flattened brick, which have a higher porosity. So one of the reasons that you get these porous bricks is the how they're made. So most clay bricks are cooked in the oven, and in quite a lot of properties, especially Victorian houses, they can be under fired. And the other thing that you can find is that cheaper bricks intended for internal walls will actually often use for the external walls, and so will have different properties in terms of their water resistance and their strength. Spalling of bricks can be quite common for in terms of the porous materials, where the protective outer face of the bricks can blow due to either a manufacturing defect or frost action, so freeze thaw. And what happens is this results in the more porous inner part of the brick being exposed to the weather, and so it will actually absorb more moisture when it starts to spall. And also you can get porous stones, so even sedimentary rocks which are used in construction are naturally porous, so such as sandstone and limestone. But a degree of porosity can depend on a few factors, such as the actual type of limestone and sandstone, where it was quarried, and even sort of which part of the quarry the stone came from. So different sort of beds from where it came from can have different properties. So not just stone, but porous mortar can be a route for moisture. So it's often necessary to specify weak mortars for, or especially for historic buildings, to prevent any cracking of the brickwork. But weak mortars tend to be very porous. So these can be rectified by either using a gauging solution when they're mixed up, so using a repointing additive which can waterproof it, or overcoating it with a brick cream such as Storm Dry. So how do you know how can you actually check the porosity of masonry? This can be done by masonry absorption tubes. So these are based on the Ryland tube or Carston tube. And effectively what is done is that this tube will simulate wind-driven rain. So when the little tube is attached to the wall and filled up to the maximum height, that will be simulating around about 90 miles an hour of wind-driven rain. And so you will measure the rate of drop of the water, and the quicker it drops, the more porous the material is. And so you do this before applying your masonry water repellent cream, and then afterwards you'd measure it again, and hopefully it would have a reduced rate of absorption.
Just on that note, and from your previous slide as well, mentioning about the kind of the weakness and the potential for moisture to enter through the mortar course, it is also worth, when you use these tubes, to take a number of readings off of the wall, including overlapping into the mortar course as well, because, you know, as the saying goes, sometimes you can have stainless steel bricks, but obviously it's the mortar course which will be the weakest part of which kind of moisture can enter the structure. So do also measure the porosity of the mortar course as well as the brick itself.
Yes, exactly. And also we found where, because we send out these tubes for people who want to measure their porosity of their bricks, and it's very key to make sure there's no leaks through the tube when measuring. So when you are putting that little mastic tube on, make sure there's no leaks, otherwise you might get a false result. So when you are looking to reduce the porosity of masonry, the most common sort of treatment now is to use colourless breathable water repellents. You can also use masonry paints or coatings, and another measure is protective renders. So the first sort of measure you can do is water repellent creams. So Storm Dry would be the most common one on the market, and effectively what these are silane and siloxane based emulsion creams. And the idea is that they penetrate into the substrate while maintaining its original appearance, so they don't change the look of the wall. And the idea is that they penetrate into the brickwork, approximately about 12 millimeters into the brickwork, and line the pores of the substrate. And the idea is that instead of blocking the pores, they line them, which allows the wall to breathe. So it's been found through testing that these sort of creams only reduce the breathability of the walls by a maximum up to about 10%. But so 90% of the water vapor will carry on passing through the brickwork. The other benefit of using them is that they can also have heat-saving properties. So by keeping the wall dry, you're preventing that heat transfer, and so that also reduces people's heat loss through the wall. So these have been found to be very effective and also have a long lifetime. So they've been tested by the BBA and found to be effective for up to 25 years.
Also endorsed by the Energy Saving Trust as well, I believe.
Yes, so they've been shown to have energy saving properties and been certified by them as well, which is actually a really good little coup, I think. So so looking at masonry protection cream as one of these measures. So like I say, the cream formulations are quite great because they have a higher actives content, which has higher penetration depths. They can also bridge smaller cracks compared to liquid water repellents. And because of the enhanced durability against UV, they can last a lot longer. And because they have a higher penetration depth, it means that anything behind the surface will also stay hydrophobic. And so if there is any erosion of the brick face, you'll still have some form of waterproofing behind that as well. So yes, that's masonry water repellent. So now we're looking at the paints. So you can use sort of masonry paints or clear acrylic coatings, and these can help to protect against rain penetration if properly applied to a prepared surface. But be aware that if used incorrectly, they can trap moisture behind them, especially if you're applying it onto a previously painted surface. So you may need to remove the existing masonry paint first using a paint stripper before applying a breathable paint on top. So if you are in that situation where you want to apply a paint onto onto a wall. The most modern method now is to use a silicone resin emulsion paint, and effectively what these are is that they are breathable water repellent paints. So they have a different binder system compared to traditional paints, which allows allows a sort of porous structure to the paint surface, which allows water vapor to pass through, while also resisting the passage of liquid water into the brick wall. It's been found that applying a water repellent cream such as Storm Dry as a primer will also give better durability of the paint. So the idea is that the silicone resin binders repel the water, but also have a higher porosity compared to standard masonry paints. So in this situation where you're applying this paint, the best sort of process to go through is to apply the water repellent primer cream first, especially onto renders. So this should be applied evenly, and that will penetrate into the render and provide a protective zone in case the paint layer becomes damaged or any micro cracks might form in the render. So basically, you're adding some form of secondary protection. And also what it does, it provides a chemical key for the subsequent silicone resin paint. So you can see here that the cream is applied by brush to any sort of window details. So that prevents any sort of splashing onto the window, which is sort of always look to avoid. You would allow the cream to soak in for about 12 to 24 hours, and then 2 coats of the silicone paint can be applied to the primed render. It's always recommended when applying paint onto a water repellent surface to apply it within about 7 days of the cream being applied. If you apply it afterwards, it may be harder to apply the paint, as there may be reduced adhesion. And the other sort of alternatives out there are clear coatings. So there are many types. There are acrylic, there are silicone resins, and there are alkyd types. There are also these silicone elastomers, which offer the best performance. So these are especially useful over the silane cream primers. And the idea is that in situations where you have quite a lot of micro cracks which can't be rectified, and the homeowner is looking for a solution in which it only changes the property the appearance of the wall slightly, it might create a sort of semi-gloss finish. These types of treatments can be used, so this is like Storm Dry CB coat. The sort of like downsides of using it is it does have reduced breathability by about 50%, but it does bridge small cracks, so it can be used as a sort of coating on the surface. And the other sort of treatments is also cladding. This provides a barrier to rain penetration, and it's quite commonly used at a first floor level. Obviously it changes the visual appearance of the building, and also the fire risks should be considered. And also, as we said earlier, using render and EWI can also be applied to fair face masonry as a barrier to rain. It can obviously change the appearance of the wall, and also care needs to be taken so that it is installed correctly. So that's looking at a porous masonry. Now we're just going to look at those exacerbators of rain penetration. So these are anything that, like we said earlier, that allows rainwater to bear on a particular section of the wall and prevent drying. So we're just going to start going through those. So one of them, like I said earlier, is anywhere where there are sort of defective guttering. So it's quite a good thing to do in terms of when you're looking at properties, is checking during a rainy day. So if someone says they've got rain penetration, it's quite a good idea for them to go outside when it's raining and to look at all their gutters and see if any of them are sort of spilling out, because that might give a clue of why they're starting to get rain coming in. So in these situations, where you have defective rainwater goods, this can cause concentrations of rainfall to bear on quite small sections of the wall. So it can allow a lot of rain to get into a certain section of the property. Especially becomes worse if there's any sort of defects or porous brickwork as well. So effectively, in quite simple terms, these should be repaired. Regular maintenance is quite a good thing to be doing when it comes to these sort of situations. So keeping gutters clear, and any sort of defects should be looked at as well. So moss on roofs can also be a problem. So quite commonly where the process is essentially is that you get birds sort of landing on your roof, depositing their excrement, and then eventually any sort of moss will start to develop on those leavings, and basically will be very common on concrete tiles or anywhere there's shaded roofs. And then will also become really apparent when there's heavy rainfall, which can cause the moss to dislodge and start to actually block the gutters and downpipes.
This is something I've experienced in my own property, not only just the moss but also grit off of the roof tiles themselves, where they've kind of like over the years have kind of blocked up and caused the actual kind of gutter itself to be much shallower than it should be, and consequently rain spilled over the top. Yeah,
so it's always good practice in those situations to get on the roof and have a look. So in this situation here, you can see that a good practice then is to remove the moss using a scraper or an extendable pole. So you can get those sort of like scaffold towers, which can be rented for about £40 a day, I think is the you can get those now. And then in those situations, you can then treat the moss with a low pressure spray. So use some form of multi-surface biocide to kill any moss and any sort of like spores in the roof tiles. And then as a sort of preventative measure, you could apply a water repellent treatment onto the surface to waterproof the tiles to reduce the amount of moss growth. Alternatively, you can use biocidal treatments, but these are being phased out due to the biocidal products regulation by the EU. So one of the other exacerbators are defective or missing seals. So it's quite common, you can see in areas where there's rainwater or sort of deposits on certain sections of wall. So these should become quite obvious and quite apparent and should be easy enough to fix. So in a lot of properties you can get poorly conceived or executed details where especially on sort of retrofit properties where a new bit has been installed, where rain can now start to bear on a certain section of wall. Quite commonly we get calls from people who have called up and say they got rain sort of penetrating the property, and then we find out that their neighbour had a garage installed next door, and effectively rain has started just shooting off the roof onto the wall directly, and so that's the reason. So all they had to do was essentially ask their neighbour to install some guttering on their garage, and that would fix the problem.
Yeah, I've seen that exact problem where it was a pitched roof with no gutter, and the roof extended up to the boundary wall between the two properties. So the neighbour's rainwater was shooting off the roof and hitting the wall of the property next door.
Yeah, so it's, these sort of things need to be looked at. So it's a good, in terms of when you're surveying a property, is also looking at other things that might have changed over time. So any sort of alterations that have been done, so you can see in this situation here, these semi-detached houses originally had parapet gable ends, but the parapets have been removed from a lot of houses on the street, causing a higher concentration of rain to basically sheet down the gable end wall, which will allow sort of higher concentration of water. So this sort of things that you just need to be thinking about when looking at properties. This is quite a common thing to find on sort of terraced houses. So non-breathable coatings. So if you keep applying another layer of paint on paint, you'll eventually start to basically trap moisture behind it. So where this is a situation, surface preparation might have been poor. And basically this allows sort of water to accumulate. You can even get these sort of water blisters, which if burst, just sort of like become a little sort of like fountain of water. If any of this moisture does get trapped, it will be unable to evaporate out. So in those situations, it's just simple replacement of the non-breathable coating. So you can get these methylene chloride-free paint strippers, or you can get sort of clay-based ones as well, which are really effective at removing the paint. Or even you can get these types of sandblasters, which can remove the paint as well. So you remove it back to a sound surface. You can then either just repaint, or you can prime the wall with a water repellent cream and then repaint with a breathable silicone paint, as we said earlier. So one of the other exacerbators of rain penetration is also where in the country are you. This little map here is quite a common one. Hopefully you might have seen it before, but this shows the areas of exposure within the UK. And essentially, the more exposed you are, the more wind-driven rain you might have. And essentially, the idea is that in areas of high exposure, the masonry should have a better protection to accommodate that. And effectively, if it's not resistant enough for the exposure zone, it may need to be upgraded. So using things such as water repellent cream, rendering, and cladding. So you can see there on the in the blue section there, which is considered the most severe exposure zones, it can actually be it's not recommended normally to install cavity wall insulation, and it's been found that quite a lot of properties were, especially in Wales, and they became damp over time. And the other thing is the aspect of the wall. So in certain areas where you need to take into account the sort of contours of the land, so the topography of the land. So depending on how high the wall is, what the roughness of the the surrounding terrain is it flat? Does it contain buildings and trees? So if a house happens to be on its own in a field, it's likely to be more exposed to the elements. But if it happens to be within a sort of cluster of other houses, then it's going to have less risk of being exposed to wind-driven rain. Periods of extreme rainfall. So during the winter of 2013-14, there was a high level of rainfall. So during a normal weather season, what you would get is that you get a summer which would dry out the wall, and then during the winter it would slowly wet the wall, but the moisture would never reach the internal surface, because during the summer it would start to dry out again. But during 2013-14, due to the high rain, it eventually started to saturate walls throughout the country due to the reduced drying. And this, especially for solid wall properties, was very common until eventually the inner face of the wall started to show dampness. And this became quite a concern, especially in the north. So records have shown that rainfall has increased greatly since the 1960s. So you can see in those comparison diagrams that compared to 1961 compared to 1995, the amount of wet days has increased dramatically, especially in the north. So these can be apparent as why we are getting more rain penetration in properties. So that's looking at the sort of primary protection. We're just going to now look at the secondary protection. This is the sort of belt and braces approach to fixing penetrating damp. So once you've dealt with the sort of primary protection of fixing the sort of underlying cause of the penetrating damp, so these are things such as like say applying that brick cream to fix any freeze thaw, and also increasing the evaporation. The secondary protection layers can be installed internally. So this is using things such as a damp resistant plaster, and also other measures will prevent future moisture ingress. So it's often been used been quite common to use impermeable membranes and tanking as a way of covering up penetrating damp symptoms, and they can be very effective. The only sort of downside is that they have the potential to trap moisture in the wall. So using these sort of treatments are quite useful if you need to blend in with an existing plaster which is quite thin. If there's any sort of salts or tar that's within the walls, that can be very common around chimney breasts. It can be quite a good way. So this is in the picture is using a tanking membrane called Dry Base Flex. But also the other downside is that any underlying causes of dampness won't be addressed. So you need to be looking at those as well. So the most common sort of best solution these days is to use a renovation plaster. So the second generation now have enhanced resistance to damp and salts, and also have a high breathability. So the idea is that these plasters are lightweight and have a pore structure which traps the salts within the plaster and prevents it from reaching your internal surface. They also have a hydrophobic additive which makes them water resistant, and also have this pore structure which allows water vapor to pass through. So they're really good for if you have a wet wall and you're looking to dry it out. You can apply this plaster, leave it unpainted for about 6 months, and that will allow the wall to dry out happily. Another system that can be used as a secondary protection is hybrid plasterboard systems. So this is using such as the express replastering system by Safeguard, and this basically uses a breathable silane water repellent cream is applied as a primer to the wall to waterproof it and prevent any sort of interstitial condensation mold. And then the plasterboard is applied using a moisture and salt resistant adhesive called Dry Grip. So this is can be used on insulated boards, but standard plasterboard is preferred as it allows the wall to dry out behind it. So this is a good BBA approved system if you're looking to fix a commercial property and also you're short on time, as it allows a quick turnaround of the property. So yeah, so just looking to recap that sort of 4-step process. So like we said, we've just gone through them now. So the first step is, as always, is to assess the amount of damp, looking to fix those primary measures, sort of primary paths of moisture, also looking at those exacerbating factors, and then as the sort of belt and braces approach is adding that second line of defence with for instance, a damp resistant plaster. So like I said, assess the property, do your surveying of the where the moisture is getting in, block any primary paths of moisture, so fixing any cracks and seals, repointing, applying a masonry water repellent cream, and fixing any render paintwork and flashings. Controlling any exacerbating factors, so fixing the rainwater goods, moss and non-breathable coatings. And secondary protection of using breathable plaster systems, which can sort of prevent any further damage of the masonry, especially during any sort of extreme rainfall events. So this will be very useful at doing that. And then the other thing to be done is just maintaining the property. So once the penetrating damp problem has been resolved, the building needs to be maintained. So regular cleaning of the gutters, checking the condition of the rainwater goods, and then fixing and sort of patching up any cracks in the mortar or brickwork, and checking the condition of paintwork. So we're just going to now look at cavity walls to finish off, I think. So yeah, where does rainwater become a problem? So cavity walls were initially designed as a way of protecting against rain penetration. That was their primary function, and the idea is rain would always pass through the outer leaf, as a single skin brick wall will never stop rain penetration. So that's why you have two skins, and the idea is that the water drips down into the cavity drains and through a weep hole, and the moisture is emitted. And this is fine for unfilled cavities, but can become a problem once the cavity has been filled up. The issues where you can get problem is where rainwater is allowed to cross the cavity to the inner leaf. So quite recently, in the last sort of 10 years, cavity walls have been seen as a good place to fit insulation. So especially when the Green Deal came through in like 2010. And therefore cavity walls sort of fell into sort of three categories. You had unfilled cavities, partially filled cavities, and fully filled. And they all had their sort of reasons for allowing rain penetration. So just looking at these three diagrams, you can see here you have three different types of insulation that can be put into a cavity, and as you can see, all three will allow moisture to pass through if they're not correctly installed. So effectively what it's showing that is that regardless of what type you use, you can get rain penetration. So this statement by the BRE just makes that point that cavity, if I read it now, so full cavity fill accentuates the role which poor construction plays in rain penetration, particularly when it involves dirty or sloping wall ties, mortar snots protruding into the cavity, or debris lodged in the cavity. Water may also cross to the inner leaf through gaps or fissures in the fill material. So because of this reason, it's important that the external face is weatherproof as possible when installing any sort of CWI. So a case study that Safeguard did looked at a place that had damp cavity wall insulation. In this situation, the CWI was removed, and then effectively the wall was treated with a masonry protection cream and localized repointing. And then the wall was allowed to dry out over 9 months before new cavity wall insulation was installed. So this it is also possible to leave the damp insulation in situ and allow it to dry out, but this may take longer as the masonry waterproofing cream. It will still take time. To dry out as it's still going to dry out through the wall, but the waterproofing cream will not inhibit the drying though.
Yes, minimal loss of permeability in it with storm dry. I think it's if I'm correct, about 5% reduction in permeability. But
yeah.
Other than that, it is a common concern where people say, will it block the moisture that's in there from drying out? Definitely not.
No.
Absolutely sort of minimal effect. So a wall like that where it is kind of, the CWI is where it will still have an opportunity to dry out and evaporate through.
Yeah, while also preventing any new moisture from getting in.
Yeah, exactly.
So where you are got CWI, one of the other issues is to get corroded wall ties, especially when they get wet. So in this situation, rainwater will track across the wall ties to the internal face. In this situation, they need to be removed and replaced with stainless steel wall ties. And it's the other situation where applying storm dry can have its benefit, as this will delay the corrosion of the wall ties as well. So like I say, there are quite a few methods of preventing rain penetration through cavity walls. So things such as clearing the debris, removing any saturated insulated material, removing any problem wall ties, and ensuring that the cavity wall insulation is appropriately installed by a reputable installer. So like I say, so in summary of penetrating damp, the main thing to do is identify the source of damp. Make sure you know what type of damp it is. Is it rising damp, penetrating damp, or condensation? Follow the 4-step process for treating it. So assess it, primary paths, exacerbating factors, and accessory protection, and treat the damp with appropriate measures that fit the building structures, the aesthetic, and the homeowner's budget. And also consider any future issues when installing cavity insulation. So thinking about past 2035 is a good place to start with in that respect. Okay, well, thank you for listening, everyone, and staying in there. If you have any sort of immediate questions, these can be submitted by the webinar question submission link below. If you have any detailed questions that you want us to answer, which we can't do during this session, these can be sent to us at webinar@safeguardeurope.com. And lastly, if you have any sort of feedback that you want to give us, please give it to us via the email address above, or give it in the feedback form below. If it's good or bad, we want to hear about it.
Brilliant, thanks Michael. Thank you very much for listening, and we'll terminate the stream now.
Oh,
Thanks
brilliant. Okay.
Finished.